Welcome to Cosmic Compass, where we journey through the wonders of space and uncover the hidden stories of the universe. From the planets of our solar system to the vast clouds of gas and dust between the stars, there's always something new to explore. Today, let's ask a fascinating question. What would it really look like if we lived inside a nebula? The answer might surprise you because, in a way, we already do. Let's dive in. Have you ever wondered what it would be like if our solar system was surrounded by a nebula? Imagine looking up at the night sky and seeing immense shapes glowing with magnificent colors stretching from horizon to horizon. It sounds like something out of a cosmic dream. But here's the surprising part. Depending on how we define a nebula, we may already be living inside one. Our home, the solar system, is currently passing through a region of space known as the Local Interstellar Cloud. How is that possible? Let's take a closer look. First, we need to understand what astronomers actually mean when they use the word nebula. Historically, the term was used as a kind of catch-all. Anything in the sky that looked hazy, milky, or cloud-like was called a nebula. Even galaxies and star clusters were once grouped under the same name. Today, however, the definition has become much sharper. When we say nebula now, we are talking about very specific types of interstellar clouds made up of gas dust and plasma. The most famous of these are emission nebulae, also called HII regions, like the Orion Nebula. These clouds consist mainly of hydrogen gas ionized by the radiation of young massive stars. The energy excites the particles, making them glow, almost like the light inside a neon sign. In contrast, there are dark nebulae, or molecular clouds. Here, no strong radiation is nearby, so the gas remains cold and neutral. Instead of glowing, these clouds absorb light, creating dark silhouettes against the stars behind them. Sometimes the two can overlap. A dark nebula might sit inside an emission nebula, with its outer edges glowing while the interior remains cold and opaque. It's within such regions that new stars often begin to form. Then there are reflection nebulae. These don't shine by themselves, but instead reflect the light of nearby stars, producing a faint bluish glow, similar to the way Earth's sky looks blue. Other nebulae are linked to the life cycle of stars. A planetary nebula forms when a medium-sized star like our Sun will one day sheds its outer layers as it evolves toward a white dwarf. Meanwhile, a supernova remnant is the spectacular aftermath of a massive star's explosive death, often leaving behind a neutron star or black hole. Both planetary nebulae and supernova remnants are brilliantly colourful, since their particles are charged and energized by the violent events that created them. Over time, though, they fade and disperse back into the interstellar medium. When we look at all of these together, nearly every type of nebula falls into one of two broad categories: glowing emission nebulae or cold, dark nebulae. No matter their type, all of these clouds share one important feature: they are diffuse nebulae. They can stretch across vast distances, sometimes spanning hundreds or even thousands of light years, yet their particles are spread incredibly thin. To put this in perspective, many nebulae contain only a handful of particles per cubic centimetre, sometimes just one. An Earth-sized nebula would weigh only a few kilograms. By contrast, at sea level on Earth, the air around you contains about 15 quintillion particles per cubic centimetre. Even 450 kilometres up at the altitude of the International Space Station, there are still 50 million particles in that same tiny space. So, when we admire glowing pictures of nebulae like Orion, what we're really seeing are vast, diffuse objects compressed into our narrow field of view. For someone inside one, the effect would be much less obvious. If you stood on an Earth-like world in the middle of a typical nebula, chances are you wouldn't notice it at all with the naked eye. That doesn't mean all nebulae are equally invisible. The Tarantula Nebula, for example, located in the Large Magellanic Cloud, is so luminous that if it were in the same place as Orion, It would cast shadows on Earth at night and would even be visible during the day. Living inside a nebula like that would be an entirely different experience, one where the sky itself would glow. So what about our own situation? The Local Interstellar Cloud, which the Sun is currently travelling through, is thought to be a very diffuse supernova remnant mixed with neutral atoms. Technically, it qualifies as an emission nebula, though one on the very edge of definition. The particles within it are blisteringly hot, averaging around 600-700 degrees Celsius, with some reaching into the millions. Yet, because there are so few of them, the heat capacity is tiny. If you were somehow floating in the middle of the cloud, it wouldn't warm you up at all. This extreme sparseness also means the cloud is practically invisible. Even with our most advanced instruments, it's hard to detect. Still, we've begun to map out its shape, revealing that it stretches about 30 light years across. Our solar system is moving through it, and in roughly 20,000 years we will emerge into a different region of space altogether. The Sun itself interacts with this environment. Its magnetic field pushes away ionized particles, creating a wake, much like a boat moving through water. Neutral particles, however, are unaffected. They stream straight into the solar system. By measuring these incoming neutral atoms, spacecraft have been able to determine the direction of the interstellar wind. Even though the Local Interstellar Cloud is not dense compared to other nebulae, it is relatively dense for our neighbourhood of the galaxy. That's because our cloud sits inside something even larger, the local bubble. This is a huge region of space where the average density is just 0.05 particles per cubic centimetre, much lower than the cloud itself. Astronomers believe the local bubble was carved out millions of years ago by multiple supernovae. Think of it like cosmic soap bubbles. Each explosion blows out a cavity, ionizing and pushing material to the edges. Where these bubbles overlap, material gets squeezed together, forming denser clouds like the one we are in now. It's a messy but fascinating picture of our galactic neighbourhood. But why should we care? Why do scientists spend time studying clouds that we can hardly even see? For one understanding, the Local Interstellar Cloud helps us interpret astronomical observations. When we look out at distant stars and galaxies, we need to account for the particles between us and them. Knowing the composition of the cloud we live in allows us to filter out its contamination from the data. It also has practical importance. The interstellar wind flowing into the solar system is a source of radiation. By studying it, we can better protect astronauts and spacecraft venturing beyond Earth's magnetic shield. In a sense, it's like understanding the weather before you set out on a long journey. So even though we may not reside inside a breathtaking nebula like Orion or Tarantula, our solar system does occupy one of its own. The Local Interstellar Cloud is diffuse, faint, and almost invisible, but it is real, with a structure and dynamics that we are only beginning to understand, and it raises intriguing questions. What will happen when the Sun finally leaves this cloud in 20,000 years? Will our cosmic environment change in subtle ways? These are mysteries future generations of humanity, or perhaps our distant descendants, may one day explore. Thanks for joining us on this journey. Until next time, keep looking up and let's continue exploring the wonders of the universe together. That's all for today's exploration. While our sky may not glow like the Orion Nebula, we are travelling through our own local interstellar cloud, an invisible reminder that even our quiet corner of the galaxy is part of something vast and dynamic. If you enjoyed this journey, don't forget to subscribe and join us here at Cosmic Compass, where we continue charting the wonders of space together. Until next time, keep looking up.